a follow-up, because I realized when I was working on the talk that I did in October 2020, which you can see on our YouTube channel, that it wasn't just this part of London, it wasn't just Greenwich that had been a centre of technology for more than 150 years. It was London, the whole of London had been a centre of technology for a long time. And it's disappeared. That subsea cable unit in Greenwich, in East Greenwich on the peninsula, is all that's left. But there's a lot of other things that have just vanished, and I'm going to take you through them. That is, a few years ago, Mary Mills and a few other people, Dan Hayton of Goliath, Stuart Ash, who's a subsea cable consultant, and I and several other people from Southeast London started a campaign to stop the neglect of this, which is Enderby House. This is a building that was then 170 odd years old. It has been the headquarters of Telcon, the Telegraph Construction and Maintenance Company, which later became Southern Cables Limited, and then it was part of STC, and then it was Alcatel Submarine Networks, which is its name today, and it's owned by Nokia, which is the Finnish telecoms equipment company. This is the part of the operation that survives in Southeast London. That's an earlier picture of when it was at its height, and all those factories along there, all those buildings were involved in making cable and making repeaters. That loading gear that you see on the riverside, a big wheel, that gantry is still there, but that's all of it that's still there, apart from that white building, centre left, which is Enderby House. Again, that's another picture of what it was like 10 years ago, 11 years ago, 12 years ago. That factory is boarded up, but the landing gear, the loading gear on the jetty is still there, and unfortunately is still there. It was last time I was down there a couple of weeks ago. That's my talk I did on 13th of October 2020. It's still on YouTube. You can see it there. And this gives the whole story of how Greenwich and Woolwich were the birthplace of the global telecoms industry and the internet. That's what it looked like in the early days, in the 1850s. Those big things there, those big circles, are cable ready to be loaded onto ships. As it came off the production line, and it goes across and sort of wheeled apparatus, and then is loaded onto those big circular carriers, and then it's later loaded onto a ship. And you can see some masts over there. It's probably not for sale, it's probably not in the right arrangement. But nevertheless, that is a huge industry, and it's been thriving in London, in Greenwich for 123 years. That's what it looked like in the late 40s, early 50s. It celebrated its anniversary, its centenary, in 1950. And that was a huge factory. Some of those buildings are still there, those down at the bottom end, which is on the main road. You can still see the shape of the building. They've got new roofs and probably lots of view in it. But what happened a few years ago, and why we, as the Enderby group, got so active, was the bit down on the riverside there had been sold off to a property development company, and they were building some big flats, which are now there, now in occupation. What we were very concerned about was that Enderby House itself, the headquarters, which probably dates back even further than 1850, probably goes back to when the Enderby family owned it, and it was a whaling operation. The Enderbys were whalers. There was an Enderby land in Antarctica, I think there's an Enderby Island somewhere, but anyway, the Enderbys were whalers, and Greenwich was a big part of the industry. That's what worried us. That's why we set up the Enderby Group, because it had just been left with this rather ramshackle fence around it, which a couple of lads from Greenwich or Woolwich on a Friday night could pull down with one, fierce go and get into it. And obviously some graffiti artists have been in there already. And now I'm not suggesting that the property developers were so minded, but my wife used to be property correspondent on the Financial Times. And she said when a property development company had a site that it wanted to clear, and if there were any problems with it, including somewhere that was listed or had some other historic interest, what they did was leave it rather than like that, unprotected. And so, just coincidentally, no doubt, this site was unprotected. We took those photographs, we printed them in a leaflet, we caused the stink with local politicians and the council, and very shortly afterwards, the whole thing was protected. We boarded, really secure hoardings across the whole site. And that's what it's like today. That bit at the left is the original Enderby house, and round the back, there is an extension, and it's a thriving pub. I last saw it about 3 or 4 weeks ago, I think it was, and it was doing good business in the sunshine. What the remains of the factory does now is repeaters. So these things, that's not a very good picture, so it comes off the Outerfield website. That's about a foot in diameter, about 30 centimeters in diameter at the thickest part, and they've fitted into optical fiber cables to boost the signal for the next leg. You can't get a cable that will carry a signal all the way across the Atlantic. Typically, you need these every 200 kilometers. And that's what is made in Greenwich. But it is the oldest, this site has a continuous history as a telecoms factory for 173 years. It's more than a factory. It's people with highly developed and rare skills, and they design these repeaters for submarine cables. And I think also you could probably say this is the oldest factory in the telecoms industry that's still on the same site. These cables cross the sea, and they deliver not just phone calls, but internet services from country to country. Those people that are outside the UK who are watching this or watching it later on YouTube, that's how it's getting to you. It's not satellite, it's these cables under the sea that connect the world. So every time you send an email to a different country, it will go through subsea cables. And this factory in Greenwich has carried messages, has delivered the equipment to carry messages since 1850. These are the cables that carry your emails, carry your Zoom calls, deliver your Netflix movies, or your family pictures. And so 10 years ago, we set up the Enderby Group, took pictures showing, as I said, the state of Enderby House. And within a remarkably short time, the developers, as I say, erected a secure hoarding around the site. And today it's a thriving riverside pub. The Enderby Group has now closed down, having achieved its aim, and it transferred its funds earlier this year to the Greenwich Industrial History Society. That is what the Greenwich Riverside looked like a few years ago. It was the heart of the subsea telecoms industry. These dots were major factories. The red dots were major factories. So Charlton there, Greenwich there, North Woolwich there, and actually further down the river, just off the picture in Erith, became the heart of the new global industry of international communications. That's what I talked about in my 2020 talk, so watch it if you like. And they built, in the first 100 years, the Greenwich and Woolwich sites made 385,000 nautical miles of the world's subsea cables. That was 82% of the world's total by the time the company marked its centenary in 1950. 82% of the market they had. And all of these dots show where people worked to make the cables. The orange spot at the far western edge, I hope as reputable members of the Greenwich Industrial History Society would recognize that, where the Great Eastern was built and launched into the Thames, designed by Brunel. After its failure as the passenger ship, Daniel Gooch took it over to convert it to be a cable ship. It laid the first 2 transatlantic cables in the 1860s, and it went on to complete many other links, including the first cable that connected the UK to India. And the green spot, that's the original site of Woolwich Poly, that's now transformed to Greenwich University, partly in the old Royal Naval College, partly downriver in the Chatham area. You'll hear about that later. Greenwich, that's Greenwich University now, that's part of it. That's where the top picture is where it started in Woolwich. Rather run-down building, seems to be rather abandoned, I'm afraid. Below it, it's a smart, wonderful site in the old Royal Naval College, which is now open, of course. You can walk around the whole site now. In the old days, when it was still the Royal Naval College, it was protected by armed guards, and nobody, if it wasn't a authorized visitor, could get there. And of course, the reason was not only was it a military site, but it had a nuclear reactor in there to train nuclear submarine crews, and not even the London Borough of Greenwich knew about it until they started dismantling it. As Mary might be willing to confirm, as she was then a councillor. I'm not sure. Anyway, but as I said, I delivered an earlier version of this talk in 2020, and I've delivered other versions to other people later, and I've got one coming up in September. But because in researching the original presentation, this is an entirely new talk, and then the 3 years since, I realized something quite fundamental. Out of this early leadership in telecoms, dating from the 1840s and 50s in Greenwich, London, and I mean London rather than Britain, London saw a remarkable coming together of research and manufacturing and financial investments in telecom technology. It's almost the equivalent 170 years ago of Silicon Valley. That Silicon Valley, that stretch of overdeveloped urban landscape south of San Francisco, that became, from the 1950s onwards, became the site of the modern industrial revolution, with entrepreneurial engineers mixing with investors and startups and established corporations to develop silicon-based technology, transistors, integrated circuits, computer hardware, the stuff we're using for this talk, leading on to computer software. And that, on the bottom right there, is Apple's new headquarters. London was like that from the 1850s onwards, but without the fancy architecture. And over the following century, telecoms led to radio, television, radar, computer technology, and telecoms include telegraphy and telephones and telephone exchanges and submarine cables. And it was all in London. And where is it now? It's gone. That's all that's left. That little red spot is Alcatel Submarine Network. That's just East London, but expand the map to the rest of London and find the remains of factories and research labs and advanced research labs right across the city and the near suburbs. There were, of course, universities, primarily King's College London and the Strand, and UCL and Imperial, and they still exist with some great people. For example, Paulina Bavel, FRS, she's one of the world's top optical fiber scientists, professor of optical communications at UCL. In 2016, the Royal Society recognized her expertise by electing her as one of its currently 1,700 fellows, FRSs. There have been only 198 women have been FRSs since the society was founded in 1660. She is one of them. Her predecessors in London discovered principles of electromagnetism. People developed and commercialized electric telegraphy, and then submarine cables to extend telegraphy worldwide. And then radio and television and audio recording and stereo and radar and computers, all from London. And computers themselves. This is Leo, Lyons Electronic Office, developed by the tea company, J. Lyons, in Hammersmith. They needed a better method of doing their accounting, doing their delivery. Their tea shops used to phone in every night how much they needed for the next day. They decided a computer would be the way to do it. It was the world's first commercial digital computer developed in Hammersmith, but it's all gone. Leo and all the stuff I'm going to tell you about, almost without anyone noticing, it's gone. We noticed a few, such as the closure of AEI's works in Charlton and Woolwich in the late 60s. This is it. Not much of it left. It's being redeveloped. I mean, it's going to be flats and studios and workplaces and so on. That followed the politically inspired set of mergers between GC, AEI and English Electric. This place closed with the loss of thousands of jobs. But for years after, London, right through until the early 1980s, still had an extraordinary collection of advanced electronics and telecoms labs, places where researchers devised the modern world. And it's strange because certainly over the last 40 years, we've heard so much about the loss of the steel industry, loss of the shipbuilding industry, the loss of the coal mining industry, and the loss of many, many other major industries in the UK. Vehicles. I'm not sure where we are with vehicles now. I'm not a car person, so I can't remember. But a lot of heavy industries have disappeared from the UK over the last 50 years, 40 years. But so has high technology. High technology, which might have been the future at one time, has also gone, which is just strange. That's the survivor. That's Alcatel Submarine Networks in Greenwich. We'll recognize that shape of those roofs. So that picture from 1850, that aerial shot, same building, same roof. It's still there. 70 years later, it's still there. The Enderby Group, notice that that name, that street name, Telcon Way. The Enderby Group gave the developers, when we first met them, a list of potential street names that they could use to recognize the history of the area, and they took us up on it. There's Telcon Way, there's other buildings, other streets. There's the Silas Field Road, the pub, the Enderby pub is in Telegraph Way. So that bit got through, two bits got through. Firstly, they saved the pub, they saved the old head office, made sure it was a pub, and certainly this summer it must be doing really well. And they used our idea for street names. And elsewhere, though, almost all of these have been replaced by meretricious housing developments. And I'm going to take you through some of those, sometimes with some vestiges of their original structures, almost none with any indication of their early purpose. A few street names here in Greenwich. That's about it. I was struck by something else as researching this. As a journalist who's been writing about electronics and computers and telecoms for half a century, September this year, it will be 50 years since I started work at Malden Grampian in Woolwich, a publishing company. I stopped in April. I'm taking a sabbatical because I got a lot to sort out. But hope to be back writing again. But as a journalist who's been writing about this, I've been into many, if not most of these places I'm going to tell you about. So it's been nostalgic looking at them again, take the pictures. I haven't been able to visit them all for this talk, but quite a lot of them. That's me. Sorry, I'll move on quickly. That was me when I was a junior journalist. I'll move on very quickly. Let's start with these two pioneers. You should know these well. There's the Royal Institution in Albemarle Street, and a few minutes to the east, King's College London in the Strand. At the Royal Institution, Humphrey Davy and Michael Faraday developed the fundamentals of our knowledge of electricity. That's why we have the unit called a farad, if you ever done physics and electronics, named after Michael Faraday. At King's College, Faraday's work was followed by James Clerk Maxwell and by Charles Wheatstone. He's the guy that invented the Wheatstone Bridge, which a lot of us also encountered when we were doing physics. And they worked out between them the fundamentals of electromagnetism, so the laws that govern what we do, how the industry, how the technology works. At the Royal Institution, Humphrey Davy and Michael Faraday developed the fundamentals of our knowledge of electricity. And then Professor Wheatstone tied up with William Fothergill Cooke, a doctor who'd been attached to what's usually politely called the Indian Army, but actually, when he left, it was still the privately run military department of the really nasty East India Company. So he was a private employee for a private army that did a lot of disgraceful things in India. Anyway, Cooke, the investor, and Wheatstone, the scientist, formed the Electric Telegraph Company, and that began the telecom revolution here in London, in fact, in the Strand. This was their equipment. One of the first tasks, as any entrepreneur such as Cooke will know, is identify your customer. Who needed the electric telegraph in 1837? One obvious candidate, the railways. Cooke and Wheatstone found customers with the cable-hauled London and Blackwall Railway, which pioneered the route that's now covered by the Docklands and Flight Railway from the city to the Isle of Dogs, and as well with the London and Birmingham Railway that goes from Euston, which needed cable haul up the hill to Camden. Of course, Euston is at the bottom of the hill. And the answer for both was early electric telegraph services. There is Highland Gardens. There is the terminus of what was the London and Blackwall Railway. It's now underground, of course, but was at one stage on that rather nice Victorian viaduct, a cable-hauled train that needed electricity to say when to start pulling, when to stop pulling, so people can get off. That's Euston, of course, as you'll recognise, the old, not quite an arch, but people called an arch that was pulled down in the 60s to be replaced by that concrete thing. And then, of course, the GWR opened from Paddington to Maidenhead on a famously flat line, because Isambard Kingdom Brunel was quite a clever guy. But it needed reliable signalling because he wanted to go very fast. He wanted his train to go fast. The electric telegraph was ideal. So the world's first commercial electric telegraph opened from Paddington to West Drayton on the 9th of April, 1839, so 184 years ago, the first in the world. Now, the Americans will say that this is the first message sent by telegraph, but that actually was 5 years and 45 days later, and Samuel Moore sent that. What hath God wrought, he said. On the 24th of May, 1844, it was also on a railway line from Washington to Baltimore, but Cooke and Wheatstone got there first. The Great Western Railway got there first. Theirs was 5 years, 45 days before Sam Moore. In London, commercial demand meant that the telegraph spread greatly. Electric telegraphy wasn't just for railways, it allowed companies and governments and individuals and publishers, newspaper publishers, to send commercial and political and private messages. Telegrams. This was the London network just a few years later after it started. And then they extended it across the UK. You see there, all the way from Dover in the southeast, far north to Dundee. Yeah, there's Dundee. heading to Aberdeen. So it basically covered the country and it went southwest as far as Exeter, I think. It's not a very good picture, I'm afraid. And they spread across the channel. There is there, and I'm sort of slightly leaping ahead, a link across the channel, world's first subsea telegraph link, 20 miles from Calais to Dover, or Dover to Calais, depending on who's going to be cut off from the cable code. And they extended the network right across Europe, right far south into Naples, across to Madrid, right across what wasn't then, but is now Germany, and Denmark and Sweden, and so on. A huge network built up very, very quickly. And this is 1856, so very few years after it all started. There was an unsuccessful transatlantic attempt in the 1850s. The cable was laid, but didn't last very long. And then in 1865, the Great Eastern loaded up with cable made in Greenwich, and it took it across the Atlantic. The cable broke midway, but the following year, it came back and laid another, all the way successfully from the west coast of Ireland to the eastern coast of Newfoundland. That's the shortest distance land to land across the Atlantic. And then, having got one cable successfully laid, it came back to mid-Atlantic, grappled up the 1865 cable, spliced the new cable to the end, and continued back to North America. Bingo, 2 cables in service. And since then, Europe and North America have been connected every day. Of course, a few other technological developments were needed before that could happen. Water conducts electricity. If you want a cable underwater, the water short circuits the connection. The answer is this. On the left there is a gutta percha leaf. Gutta percha is something very like the rubber plant. It's grown in Malaysia. It's been known in Malaysia for a long time. Like rubber, it produces a sap, but unlike rubber, which just goes soft and you have to add sulfur to vulcanize it, it crystallizes into a hard material, a really hard, rigid material. Malaysians used it as a material from ancient times, and John Traviscamp, botanist, brought it to Europe in 1656. It softens when immersed in hot water, which isn't a problem you get in the sea, and then it hardens again as it cools. And it's also waterproof, and it's very handily an electrical insulator. So it's perfect material for putting around an electrical cable, a telegraph cable. There was a big industry before the telegraph industry got involved in making gutta percha goods, speaking tubes, jewelry, stuff like that. Really weird stuff. Speaking tubes were quite good because you could have one end outside your front door and one end upstairs or in your servants' quarters. This is an age of servants. And you could find out who was at the door and decide whether to answer it. This was the Gutta Percha Company showroom at 98 New Bond Street. That's the original building, now used to close, but it is clearly the original building. They had 2 places for production. One was in Silvertown, and one was here in Forth Road alongside the Regent's Canal. The canal is on the other side of that building. This is an access road. There's the canal runs from, the main canal runs into a sort of siding from the Regent's Canal. Cook and Wheatstone's Electric Telegraph Company were the first project to connect London with Birmingham and Manchester and Liverpool. Their wires were suspended from poles normally, but they needed insulation. You know, it can be a bit wet in Manchester and Liverpool and Birmingham and London. So you needed insulation. And they tried tar, and they tried wax, and they tried pitch. And Michael Faraday, no less, said, how about gutta percha? And the people who actually did try it successfully were these guys. They were the Siemens brothers. Wilhelm Siemens is on the right. He later became William Siemens and later Sir William Siemens. He came to London to set up a factory for the company in Charlton. The guy on the left is Werner von Siemens, his brother. And they had another brother, Karl Heinrich, and they set an operation in St. Petersburg. And Siemens is still a huge company based in Munich with big premises in Berlin. And it's a global company. It's not really in the telecoms industry anymore. It merged its operations about 15 years ago with those of Nokia, become briefly Nokia Siemens Networks, and now it's Nokia Networks. But they were huge, really big operation, and they decided they wanted a UK factory because UK, and specifically London, was the heart of the telecoms industry. And they built this. Now that red bit, this is what they call Woolwich, but was actually Charlton, mostly in Charlton. That's between the Woolwich Road, which is down here to the southeast, and the river, which is right at the north end. And most of that estate is still there. The red bit's the earliest, from 1863, 1865. Then it spread outwards and eastwards, and then southwards, and the latest bit were the green ones, and the yellow ones, 55, 1956, 1953, 1957, right along the Woolwich Road, until it was closed about 15 years later, when Arnold Weinstock decided to simplify his new empire, GCAEI, English Electric, by shutting this all down. A lot of thousands of jobs. But the industry was thriving. As you see, this was a big factory by the 1880s. And there was another big move that Siemens Brothers, Charlton, I'll call it Charlton because it's mostly in Charlton. The border with Woolwich is here, Warspite Road. This bit that's white, unmarked, as is the Woolwich Arsenal, of course. And as you will know, if you're a map fan like I am, all maps until the last couple of decades showed all military sites with no detail whatsoever. They were just white, no detail, not even rivers, rarely contours if they're ordnance survey maps. So it's always quite easy to identify a militarily important site by looking at an urban site or even a rural site, finding it wasn't on the ordnance survey map. So, well, there we are. That's just wanting to identify them. But anyway, in January 1849, the UK operation of the Siemens Brothers worked with the South Eastern Railway, obviously, which went from Charing Cross to Dover, to lay 2 miles of gutta percha insulated telegraph wire from a ship, Princess Clementine, in the Channel, and they successfully sent messages to London. This is a Punch cartoon. The trial worked. 1850, they built a subsea cable all the way from across the Channel from Dover to Calais, but it survived only a few hours before the insulation gave way and messages became garbled and then non-existent. They were still working on insulation. Second attempt was better. The cable made initially in Wapping High Street, and then after a patent dispute in Gateshead by Newell and Company, and on the Surrey Canal by Keeper and Company. And Keeper and Company became part of the Enderby Group later on, only a year or two later. I tried to find the site on the Surrey Canal. I've walked up and down through that rather nice park that follows the Surrey Canal, and I scoured all the survey maps, and I can't identify the site at all. Nothing that says cable factory on any of them, sadly. Anyway, and all the addresses in all the directories just say Surrey Canal, Southwark, or Surrey Canal, Camberwell. Surrey Canal, Camberwell, I think. Anyway, by 13th of November 1851, Dover and Calais were connected by telegraph, by Siemens and I guess, South Eastern Railway. But there was a telegraph line, and England and France have been connected ever since, apart from times of war, I guess, in the occupation of the Second World War. But following year, November of 1852, there was another development, and it's really quite cute, I think, because throughout the history of telecoms and technology, there is always sort of, wow, we didn't expect we could do that. So when people invented mobile phones, and particularly 3G and 4G mobile phones, nobody said, oh, this would create sat-nav. This would create an opportunity for Spotify or Netflix or stuff like that. This would allow you to WhatsApp your friends and family across the world for zero charge. It was an unexpected benefit of the subsea cable industry. So what happened was, this was, as I say, something that wasn't planned. South Eastern Railway carried along its track the first Greenwich time signal. It obviously came from this place. That ball goes down at 1 o'clock GMT every day, but the clock, the great Shepperton clock there, has a time signal. You used to have to be able to go to Greenwich to see the time, to check your chronometers, to set them, and then head into London and exchange them with other people, excel the time with other people. And the Southeastern decided it could carry the signals by electric telegraph. It chose Lewisham Station, not Greenwich Station. I'm not sure why. Possibly, I have a sneaking suspicion that they were still, the observatory was still a bit unhappy about the presence of Greenwich Station because they thought it was shaking its instrument. So Lewisham was well down the hill, well out of the way, wasn't affected by, it didn't affect, the trains going through Lewisham didn't affect the astronomical instruments up on the hill. So they went down to Lewisham and then across the line, along the line into London Bridge, into Cannon Street, and to this place, which is called Founder's Court. It's a rather bad pencil drawing, but the building is still there. It's in Locksley. And it meant all the clocks in the city and across the country could be coordinated on Greenwich Mean Time, or railway time, people called it. And this was the beginning of standard time in the world, products made in Greenwich, cables made in Greenwich, and a service from the Royal Observatory in Greenwich changed the world. It took another 28 years for the GMT to become legal standard time for this country, a law of 1880. And then another 4 years for GMT to be accepted globally at the conference in Washington as the basis of all time zones. But without the electric telegraph from the Royal Observatory here in Greenwich, using technology built in Greenwich, none of that would have been possible. So add standard time to the benefits we've got from London's 19th century record in electrical technology. Let's move on to another. That's Guglielmo Marconi. He was born in Bologna. He's not an instant connection to Southeast London, but I'm covering this, talking about the whole of London. He was born in Bologna in Italy in 1874. He grew up at his family's Villa Grifoni, just to the south of Bologna, where he developed a fascination with electrical engineering and the recent work by Heinrich Hertz of Germany. He's the guy after kilohertz, megahertz, gigahertz are named, and Oliver Lodge, who was a British scientist in the electromagnetic wave. That was the upper floor there with the shutters closed because it was a hot summer day when I took this picture. It's a window of his lab where he first transmitted radio waves in at the Primavera, spring 1895. He sent the signal across the hill, across the fields, out, but his family was rich. He sent the signal across the hill in order to work out whether the signal had been received or not. He sent one of his servants. I told you it was a rich family. He sent one of his servants with a shotgun to watch out for the signal on his equipment and then fire the shotgun when he received it. And Marconi was in that window there you see at the top and heard the shotgun and he knew it worked. Incidentally, as a remarkable fact for you, at least I found it remarkable when I saw a short newsreel film of Marconi at Telegraph a few years ago. Marconi spoke English with an Irish accent, not an Italian accent. That's because his mother was Annie Jameson of the whiskey family. So she married the elder Marconi, went to Italy, and so their son Guglielmo learned from the English speaker in the family. Villa Grifoni is now a museum maintained by the University of Bologna. It's one of the universities, the oldest universities in the world. It's the place where the term alma mater was derived. They have this ridiculously large statue of their hero, with me alongside as a scale object. So that must be, I'm 1.7 meters, so that's about 3.5. So we're talking about 7 meters high, 9 meters high, that statue. It's ludicrous. But there we are. Because Marconi was half British, because his mother was Irish, and Ireland was still part of the UK, he came where else? And because it was a preeminence in telecom technology, he came to the GPO in London. GPO already ran the telegraph system as a monopoly across Brixton, Ireland. So Marconi brought his invention to William Priest, who was the chief engineer of the GPO in the city, who'd earlier studied engineering at King's College London, just down the road from headquarters of the GPO. Priest and the GPO welcomed Marconi, unlike 30 years earlier, when the same engineer famously, or maybe apocryphally, told Alexander Graham Bell that there was little need for telephones in London as we had enough messenger boys. But Marconi came to London, started developing his technology here, though the company later moved out to Chelmsford. But of course, then started the BBC, British Broadcasting Company as it was, in the Strand, and the place is still named. There's still another plaque on it. So this is where the BBC started. It then moved to Savoy Hill, which is where what was the Institution of Electrical Engineers, but previously was the Institution of Telegraph Engineers, is based. And then, of course, in the early 1930s, moved to Broadcasting House, where it still lives. And that takes us to the next one. Sorry, not sure where this has come from. I'm going to talk about how this led to London being what I call the Silicon Valley of the 1850s to the 1970s and 80s. Now, Silicon Corridor or the Silicon Motorway or something was a very fashionable concept about 20 or 30 years ago, because a lot of US computer companies, tend to set up in Slough, in Brunel, in Reading, in Newbury, in Basingstoke, in Swindon, and occasionally in Bristol and Bath. Very rarely north to Oxford, very rarely across the Bristol Channel. But that split between Bristol and Slough was software central for US computer companies for a long time, still is to some extent. And it was called the M4 Corridor, fairly unglamorous bunch of, they didn't make things, it was a very unglamorous bunch of office blocks. There we are, this is Bournemouth University. I produced this to show where all these places were. The reason, of course, was that name right at the far eastern end of this map, Heathrow Airport. People like to get off their planes from Dallas or New York or Silicon Valley or Phoenix or other places like that, and just get in a taxi and head off to Slough or Bracknell or Reading, just a few miles to the west. It is much simpler. Anyway, but back to that corridor, the early days of that corridor in Hayes, and go back. Yeah, just there, just north of Heathrow and Junction 4B, is a place called Hayes. And that's where EMI became a really significant company. But before that, let's talk about John Logie Baird. This guy at the bottom right. He was born in Scotland. In the 1920s, he had a lab in Soho, above where Bar Italia is now. And that Bar Italia dates back to the mid-50s, I think. And he developed a mechanical form of television. That's the Baird televisor. That's a picture of him twiddling his knob. He developed it in that upper floor there, which is still part of Bar Italia. It's got a blue plaque. He first demonstrated television. He had spinning discs that produced a few images a second with just about 30 lines. It wasn't high resolution. Then a few years later, he moved to Longacre. Got better premises, including a studio in this building in Longacre, from which Gracie Field, among others, broadcast on his television channel. He used the BBC's wavelength, radio wavelengths, for sound and picture, its early stations. This plaque on the top right there says, from this site, John Logie Baird broadcast the first television program in Great Britain on the 30th of September, 1929. Now this, I don't know quite when the first American television broadcasts were, but they were about maybe a year or two before that, also mechanical at that stage. So Britain and London was only a year or so behind the Americans at this stage. But what differed in London was the enthusiasm, not in the BBC. John Rees, the Director General of the BBC, was very sceptical about television, but the government was very enthused about starting a public television service. And they wanted one. They were impressed by Baird. Baird was a great publicist. They were impressed by him, but out in Hayes, just to the north of where Heathrow Airport is now, certain Alan Blumlein, who's the guy on the right, thought there must be a better way of doing television than Baird's whirling discs. This was Hayes, the EMI complex of Hayes at the height of its development, where EMI, which used the trademark His Master's Voice, pressed its records, many of them, and the lab, and had its lab, alongside the factory, which was the birthplace of a host of inventions, many of them thanks to Blumlein. He invented a technique for stereo audio recording in the 30s before he went on to think about television. Look at that picture. That picture, I think, is from the 1960s, early 60s, I think. It's hard to date. There's a British Railways train going along there, but there doesn't seem to be an engine. That's the main line out of Paddington, is on the bottom, out to the left of the picture, the right of the picture, and Hayes Station is just down to the bottom here, and off Reading and Slough and so on are off to the left of the picture. That mast in the top right of the picture was the world's first television mast. It was still there into the 1970s. I remember seeing it from the railway and seeing it from my visit to Hayes. And it should have been preserved as an ancient monument. It was a valuable piece of British technological history, but sadly, EMI pulled it down. In the Hayes factory, the Hayes site is unusual in that it does pay tribute to the developments that went on there, and particularly to Alan Dowd Blumlein. There were a lot of plaques in the ground paying tribute to his work on telecoms, in amplification, sound recording. Long-tail pair is a description of a type of circuit, stereo, radar, television, and more radar, HS2 radar. That's hydrogen sulfide. It's called H2S, not H2S, HS2, H2S, because it stank. They thought it was really good, and hydrogen sulfide stinks like anything. In Hayes, there's also that picture at the top right is the original EMI logo. and it's there on the building at the far end of Hayes and Harlington, of the site, which is at the far end from Hayes and Harlington station, which is a lot better than it was. Used to get a whole smoking nasty diesel from Paddington, and now you can get the Elizabeth line. Like most of the other sites that I'm going to talk about, this has largely been converted to housing. But at least in Hayes, there's a tribute to the importance of the place. Not just Blumline, but Nipper, the dog that was on HMV records. Hayes is where he and his colleagues invented what they call the first high-definition public television system. 25 frames a second, 405 lines, black and white, but BBC One and ITV were still using it in that standard until the 1980s. By then, everybody got colour set, and they faded it out in the early 80s. Hayes, as I said, was a bit of a trek away. EMI demonstrated its results in early electronic television to MPs and the BBC and the public, opinion formers and so on, at its studio, Abbey Road. It's still a place of pilgrimage, but not for its role in demonstrating television. That early blue plaque you see on the left is Sir Edward Elgar, who conducted in that building for the recording. Pretty good, but not for the world's first demonstration of electronic television. Here, the BBC, the big government gave the go-ahead to the BBC to start a television service. They said it should alternate between the Baird system, the electromechanical system, and EMI's electronic system, which was then called EMI Marconi, because in Chelmsford, Marconi's company developed electronic cameras. Everyone quickly realized the Baird system was doomed. Baird had meanwhile moved out to Sydenham, where he had a new lab in the Crystal Palace with his transmitter on one of the original water towers. And I don't mean in the Crystal Palace area, SE19, it was the original Crystal Palace. He had his lab. And it burned down, of course, in November 1936, which was just a few weeks after the BBC started its trial. It wasn't his fault that the fire started, and the Baird system was doomed anyway, even though this image on the left shows he was moving to an electronic system. There's the man with the inevitable pipe looking at an electronic picture on a cathode ray tube. That was one of Baird's pictures. But John Logie Baird had a great role of getting the BBC and the industry excited about it all. A bit further out still, I'm pursuing my story of London's role in telecoms and technology history. A bit further out still is Kingswood Warren. Sorry for the bad picture. It's a former country house. It's outside Greater London administratively, but inside the M25. It's where the BBC housed its research lab from 1948 until 2010. Huge number of innovations came out there. It's another one that I visited. I heard a demonstration of NICAM digital stereo that the BBC had developed TV there. The researchers at Kingswood Warren also developed CFAX, that information system you see on the right, which I taught several stages of its development in the 70s. They worked on high definition TV, a real high definition, not what that was being offered in the 30s, and on digital audio broadcasting and satellite broadcasting, and what the BBC calls red button services, interactive services, and lots more. It was an extraordinary lab. It was an isolated country house. It's now, like all these things, an isolated residential development. They've converted all those internal spaces into flats, built more around it, and it's a gated community, like so many more. And we'll come to more gated communities. If you can bear with me. Let's move from the edge of London northwards to Brixton Road, where Decca had its lab. Decca was EMI's great rival. This was its headquarters. It was a leader in audio recording, along with EMI across the river to the west in audio recording. In the war, like many others, it diversified into military projects such as sonar for submarines and radar, and navigation, invented a company called Decca Navigator, which allowed ships, navigators to know where they were to within a few hundred meters. Not GPS, but for its time, it was pretty bloody good. There were Decca Navigator areas in places like the English Channel and other places of high shipping around the world. Decca's main labs were in New Malden. This is what I didn't get down there. I didn't have time. This is a Google Street View picture showing the old, one of the centres of London's technological heritage, and it's just a wreck. Sorry, it is just disgraceful. Let's move back further into London. This was once the home to Pi TMC. It was one of the smaller telecom companies in London, Martel Road, SE21. Now, yet another block of nondescript service offices, though rather better designed than most. It's called Park Hall. Not sure why it's called Park Hall. Pi was based in Cambridge. Here, Pi Telecommunications, but it bought the Dulwich-based telephone manufacturing company, and I say all that's left is that rather back. That rather fancy building in SE21, but it's not telecoms anymore. There's no engineers working there. Nor are there in Pi in Cambridge. That's all gone. Almost all their buildings have gone, sadly. Oh yes, that's what Pi did. I mean, it did radio systems for tanks. It did television sets, and it recorded things. I can't read that label, but that's a Pi label. It was a big recording company. Building I never went into, yet the closest to where I live, is a rather strangely isolated laboratory in Blackheath. It was an outstation of the vast factory in Charlton and Woolwich, and it was where some of the pioneering work was done on electronic telephone exchanges in the 60s and 70s. Now, this building, of course, isn't the original. It was a steel-framed industrial building that was demolished only 20 years ago, I think. It was still there when I was walking the kids to school, and our youngest is now 30. I remember seeing it being pulled down and seeing the building work, and a pastiche of a Georgian building was put up in its place. No trace of what it was used for. It developed some of the first electronic telephone exchanges, or engineers developed some of the world's first electronic telephone exchanges here in Blackheath. New Southgate, north of the river again, and this is New Southgate, which was the factory and labs of STC. That was the company that for many years owned the telecoms cables factories in Greenwich. This building was built in 1937 alongside the railway line, just north of King's Cross. King's Cross is to the right. New Southgate Station is also to the right, and it's going up towards Hatfield and Stevenage. It was rebuilt a couple of decades ago under the ownership of Nortel, which took over the STC business. But then Nortel went bust in the early years of the century. And now it is, of course, a housing estate. One of its claims to fame is that its designers and engineers produced the trim phone. That was BT's name for it. But STC preferred the name of Delta phone. And yep, I met the engineer who designed it in New Southgate. One of the curious things about it was that it had radioactive tritium cells in the dial, one behind each digit in the dial, so that you could see it in the dark. And yes, it did glow. In my flat in Brixton in the early 70s, the mid 70s, in my flat in Brixton, I had a couple of trim phones just like that same color, and they glowed in the dark. It was really quite spooky, but it was not a good use of radioactive material, and eventually they phased them out, and they replaced them with push button phones without radioactive glow in the dark buttons. While we're on the subject of telephone handsets, This, any of you that's my age or even maybe a bit younger, will remember this absolutely standard GPO phone. It was called the 746. It was developed in that factory in Woolwich for the centenary of Siemens Brothers' presence in the UK, according to somebody who worked there that I was in touch with recently. That picture, amazingly, was taken just last week in Paris. It's a electronic version of the old dial-up phone. It's not a real dial-up phone. It doesn't produce those clicks. It produces tones like you get off a phone these days, and it's made in China. So it was designed in Woolwich, built in a number of factories across the UK until the 80s, I think, when it stopped, and now made in China as a pastiche. Sorry, it's just, I'm getting depressed about this. Anyway, before I finish, I'm going to mention some of the later triumphs of EMI and Hayes. The grain scanner, which this guy, Godfrey Hounsfield, developed more than 50 years ago, and he won the 1979 Nobel Prize for Physiology or Medicine. This machine that he developed was the grandfather of all those scanners, which are almost routine in hospitals now. Even in veterinary surgeons' premises, they scan dogs and cats and things. This guy developed it. Earlier in his career at EMI, Dr. Hansfield had worked on guided weapons and then on an old transistor computer. In the late 1960s and early 70s, when Hayes was thriving on money from the Beatles, because remember, EMI had the rights to the Beatles, and Hayes was where they pressed all the Beatles records. It made them a lot of money. With that money, they took a gamble on the scientific technology of scanners without a detailed business plan. So, you know, that's one of the triumphs of London's investment in telecoms and technology that we don't have anymore. We'll move on to another alumnus of London that I must mention. Someone who else won a Nobel Prize for work done here in London. This is Charles Cow. He was born in Shanghai in 1933. He moved to British ruled Hong Kong in 1948, so he was only 15. He then came to Woolwich Poly in South London to take his A-levels. So Woolwich Poly then did A-levels as well as degree level courses. Studied in Woolwich. He then joined STC while doing a PhD at UCL as an external student. And as well as its subsea cable factory at Enfield Wharf, STC also had a factory in North Woolwich, just through the foot tunnel from Woolwich Poly. No longer there, but there's the Standard Trading Estate on the site, and I suspect that was named after Standard Telephones and Cables that was there first. Cow and his wife, Charles Cow, as I said, developed optical fibers not in Woolwich, not in North Woolwich, but in Harlow. Charles Cow and his wife Gwen, who was also an engineer, who were married in Blackheath, by the way, moved out of London to Harlow, where he joined Standard Telecommunication Laboratories. That was STC's R&D centre, and it was one of the world's leading telecoms labs. Okay, it's not in London, it's just across the M25, most of the way to Cambridge. But there we are. There, his boss was Alex Green, the pioneer of turning telephone sounds into digital signals, a technique called pulse code modulation. Reeves and Cow and the others there at Harlow were some of the champions of telecoms and technology innovation and research until it all shut down. STL, as I said, Cow and his colleague George Hockham invented optical fibers, which now, that map I showed you right at the beginning, subsea cable map, all those are fibers invented by Charles Cow and George Hockham in Harlow, just outside London. Cow got the Nobel Prize for physics. Let me move back. Okay. Yeah, that was the original factory that STL was in North London, and then it moved to Harlow to this factory here. Now it's pulled down. It was pulled down many years ago, and is now a data center. Cal got the Nobel Prize for Physics in 2009. He was knighted the following year. He didn't deliver his Nobel speech because he'd already got advanced Alzheimer's. He died in 2018 in California, where he'd moved with Gwen to be close to their children. Now, stay in London, back into London. It's Dollis Hill. No sign of where the GPO built the world's first electronic computer under the direction of this guy, Tommy Flowers, another guy who trained at Woolwich Poly, working to the ideas of Alan Turing, that mathematical genius from Cambridge, who went to Bletchley Park in the war and was a central part of the code-breaking work there. Dollis Hill, the old post office research centre, is still there. Its main building is called Chartwell Court. It's not, but there is a Flowers Road. The whole hilltop site is utterly depressing. It's a real gated community. These doors open when a car comes near. You press your button if you're a driver. You open the gate, it closes behind you. You don't want a hoi-polloi getting around there. There are some flats just on the outside. There is a Flowers close called Hammersmith Flats or Code Court, and these mysterious balls, which is a useful word to remember. No, nothing that I could see when I visited showing what it was there for. Nothing to explain why, nothing to explain what was done. The world's first electronic digital computer was built here in Northwest 2. No sign of it. But this is one of the places I never visited. I was at the opening press trip to Lewisham, which is where the GPO and now BT moved its researchers in the 70s. That's just outside Ipswich, on the site of an old RAF airfield. And you go, that's it, that's Martlesham. That's what it's like now. Quite a splendid building. Let me finish in Wembley. That's not Wembley. Sorry about that. Oh, okay. I put this in at a later stage. This is another place that develops electronic computers. Where is it? Elliott Brothers. People who've been living in Lewisham for many, many decades. I remember this is the factory that is where Tesco's is now in Lewisham. It was Elliott Automation. It was Elliott Brothers and then Elliott Automation. It made electronic computers in Lewisham. It was almost impossible to find any trace of it. Most of Elliott's work was in Boreham Wood, in North London, and in Rochester. But Lewisham was a really key site. Nobody knows. It's there. Go visit Tesco's. Go spend your money in Tesco. There's no sign that this was a significant place in British technological history and London's technological history. And Tesco's, I hear, is about to hand itself over to more flats to be built with a supermarket underneath. I don't care. Anyway, let me finish in Wembley, where GC had the Hearst Research Centre, named after Hugo Hearst, one of the founders of the company in the late 19th century. And I shall repeat here the old tedious line that British GC had no connection with the US company General Electric. That was a fight that went on for decades and decades and decades. It was only resolved by the self-destruction of the UK company GC. And General Electric seems to be following the UK company's lead. It's about to split itself up into about 4 or 5 parts. In the late 1960s, GC bid for AEI, which had the factory in Woolwich and the research lab in Blackheath. It merged with English Electric soon after, under the favourable eye of Harold Wilson's Industrial Reorganisation Corporation, and English Electric included Marconi, and somewhere in there was Elliott Automation. After the takeover, GC kept the Hearst Research Centre in Wembley. Most of it is now boring housing estate. Look at it on the top right there. It's called Hearst Crescent, but there's nothing to explain why it's called Hearst Crescent. Down the back, there's Hearst Hall. Nothing to explain why it's Hearst Hall. That's obviously the original name of the building. And there's an Osram Road, because Osram was a light bulb brand that GC made. Nothing to explain. But it wasn't just a research centre for GC's day-to-day activities. It was also where the cavity magnetron that was invented in Birmingham University during the Second World War as a research project was turned into a producible project that could be used in wartime radar equipment on aircraft. It was one of the products developed in Wembley to production status and made in Wembley, made in London, that helped win the war. And it was, by the way, while testing the cavity magnetron, that EMI's Alan Blumlein was killed. Plane crashed on a Sunday morning. Blumlein, as I said, was from EMI. He was testing a device from GC, but it was wartime, so they worked together. I will finish. Oh, yes, and there are the University of Birmingham. That's a cavity magnetron. It's only a few inches across. Generated really powerful radar signals, hugely more powerful than they've been able to develop at Birmingham University. They've got a plaque there to celebrate them, and that's there. You see how big the cavity magnetron is. They're holding them in their hands. I'll finish with a personal story. In the mid-1970s, when I was a junior journalist on the Engineer in Woolwich, I wrote an article about how UK electronics companies, Plessey and Ferranti and GC and so on, weren't really interested in commercial microchips or microprocessors for business applications. In California, companies like National Semiconductor and Intel and other companies seemed very excited about such uses. In the UK, though, as I wrote in my article, I was being a bit tendentious, they made them for the military on a cost-plus basis. In other words, they send the bill to the Ministry of Defence, and the Ministry of Defence adds percentage and sends the money back. They shunned commercial work, is what I wrote, and they were busy lobbying a sympathetic government to get lots of aid. This was his government, I guess. Anyway, a few days later, I got a phone call from GC's press office in Mayfair. They had press offices in the best facilities, inviting me up to Wembley, a great opportunity. And there I was confronted by GC's head of research, Sir Robert Clayton, who gave me a right bollocking for daring to criticize the company and its policy. But he didn't show me that I was wrong. He didn't say anything that I was wrong. I was just being a bit rude for saying what the truth was. Sadly, I couldn't find a picture of Clayton. I haven't got that book. It's available on a book, but it's about 100 quid, 200 quid, but they didn't print very many. Anyway, it's the history of the GC research laboratories, and when I win the pool, I might buy it because it's obviously got the story of what went on there. And it has a great history. It's a GC research centre, like EMI in Hayes, like AEI, EMI in Hayes, like AEI in Charlton and Blackheath, like SDC in Greenwich and Harlow, like the BBC in Kingswood Warren, the Pi TMC in Dulwich, and the GPO in Dollis Hill, and all the others, DECA in Brixton and New Malden, and the others. It employs hundreds and thousands of top-class researchers and scientists, and lots of other highly skilled, high-tech industrial workers, highly educated. And they've all gone, all with the exception of Greenwich. It's all gone. There's nothing left, absolutely nothing left, except that glass fibre dog in Hayes and the plaque on the floor in Hayes. And that's it. Okay, thank you. You need to unmute yourself, Mary.
I was just saying thank you, and a bit of a breathless run through. And I think there's probably whole lots of other things that could be said. And the background about the instrument making industry, which preceded it, and lots of other things. I was just going to do comments, quick comments, and then hand it over to anybody who wants to ask questions. I'll comment. One is, I don't think the Elliott factory was on the Tesco site. I think that was the brewery.
Oh, it was. Yeah, sorry, my mistake.
Housing. on the site. There is housing now on the Century Works site. The other thing is, which you've missed, of course, is the first ever local government computer centre built in Stockwell Street in Greenwich. And
Yes.
pulled down about 5 years ago.
The places where they were developed rather than, I mean, there were lots of software shops, lots of software houses around London, right in central London as well as Greenwich. Yeah, the Stockwell Street one was notable because it's the first local authority one. But yeah, that's where things were being made. Yeah, yeah.
Anyway, have we got any comments, questions from our audience?
One small comment about Stockwell Street. There were instrument makers during the 17th and 18th century there, and it's the whole continuing tradition of very fine engineering. And what I think we can draw from what Alan has been saying is how it was integrated with living. It wasn't, as it is now, ghettoized somewhere else. It was actually within the residential life of people. They didn't have to commute. They could just walk down the road to work or in their own homes.
Yeah. Up to a point, yes. I mean, by the 1930s and 40s, it was mainly in those big EMI style buildings, I think, and Dollis Hill and so on. But yes, before that, you were right. Yeah.
Well, there was a big factory called Instrument Makers out at New Eltham and Stanley's. I mean, there was a bit of tradition, I think, Greenwich, Troughton.
Well, there was I don't know about New Eltham, but Burkitt-Gray, just around Sidcup, was also an outpost of STC. I think they probably bought it. There were a few others. There was some really quite advanced radio makers, a company called Burkitt in Blackheath, and then in Dartford, or maybe a bit further down the river. Yeah, there were all over the place. Yeah. Yeah.
Perhaps we should do a directory, South London. Anyway, anybody else got a comment?
Yes.
Richard, come on, I knew you would.
The establishment to the east of Siemens was the Woolwich dockyard, not the arsenal. The arsenal was a lot further east.
Okay, you're right.
Now, one of the things about the dockyard in its later days was that it was where the Navy introduced steam power to its shipping. And the school, that they built a special school, which is still there in what is now run by the co-op, to teach it. And it was one of the other learned institutions of its day, as well as the Woolwich Poly, and also as well as the Arsenal.
Mm.
Yes, a very good point, Richard. And of course, there was early introduction of steam power, steam engineering in the dockyard, and had the wonderful, enormous Naismith steam hammer, who incidentally was very keen on astronomy. He was so successful, he was able to retire very early and endowed workshops for the blind, including the one in Greenwich.
Mm. Good. Any questions or points or observations? Or you all completely?
I worked in the STC labs at Burkitt-Gray for a holiday job.
Oh, really?
Many years ago. I think they were more concerned with product development than with real research. So I spent my time preparing circuits for the engineers who wanted to have desktop phones, desktop speaker phones, that sort of thing.
They also had ITT semiconductors, I seem to remember.
That was probably later. It wasn't ITT when I was there.
Okay, yes, right. I can even remember the phone number. It was 300 3333. There we are.
I mean,
The other thing about the trim phone was that nobody worked out that it was too light. So when you turn the dial, it would twiddle off the desk, which is why they went back to the good old-fashioned ones with the solid cast iron base to keep it stuck on your desk.
It also had a very short curly cable, so it's pull.
Yes, if you pull the handset, you pull the receiver off the desk.
Yeah, but it was a nice phone. As a geeky journalist, I had a pair of phones. Rather nice. Okay. Any more questions, Mary? It's really
Nothing.
nice. I've been rattling on for an hour and 20 minutes or so. So
one other thing, which I'm not sure whether everybody knows already, but my wife and I got married at Hamilton House Hotel on the edge of Blackheath. Well, not married, but had a reception there in 2005, and the restaurant there was called Enderby's.
Yeah.
So I don't know if that was Enderby's, the Enderby family house.
where is that? Which hotel is that? Sorry?
Oh dear. Just if you go down Blackheath Hill,
West Grove.
there's a stretch of the heath between you and the road which runs level to is it Point Hill Park or something like that? It's in that area.
Yeah.
It's reverted to a private house now.
Yes, that was one of the houses the Enderbys lived in. The first house they lived in Greenwich was just down the hill, actually in Hyde Vale. But then various branches of the family lived in various houses, including houses in what is now West Grove. Yes.
Ah, right.
Thank you.
And thanks to Elizabeth for pointing out Enderby Island. I knew there was an island called Enderby just off New Zealand. Yeah, nice. Now a sort of nature reserve, and there is an Enderby land in Antarctica. Yeah.
I think one of the things about Elliot's, I mean, just in brackets, I'm fascinated to find they invented speedometers, which weren't seen necessary on early cars. But the sort of systems works they were setting up in industry and so on, I mean, it doesn't get much publicity. It's not anything people talk about. They talk about, computers and telephones and things. But all sorts of electronic devices were Elliot's really plowed ahead with and were very important.
Yeah, they were. And there was also a company in Cricklewood called Smith's Industries, which was also doing a lot of vehicle instrumentation and aircraft instrumentation. I think it might still be there. I can't remember. I haven't heard. It's probably changed its name, like so many others. But yeah, I mean, they were all over London. It was just extraordinary that we had.
As you whisked along, did I miss Putney? Did you not mention Putney? The ICL?
Sorry?
ICL? Putney?
ICL, no, I didn't talk about ICL. ICL's main manufacturing was in Hertfordshire and Manchester, as far as I remember. And they had a big office in Putney, which, yes, I mean, that's where their headquarters was until they got taken over by Fujitsu. But a lot of their manufacturing, a lot of their research was outside London. So I had to draw a line somewhere, Mary. So, yeah, and I think it was I just found it extraordinary. Following on from that talk I did in nearly 3 years ago. Goodness, we've been doing these online talks for 3 years. And when I did that talk, I realized that there was so much else in this whole area. If you widen your spread out to the whole of London, or just across into Harlow and so on, there is just so much that London was a big technological city, and it's just gone. It's really just gone. Apart from Alcatel in Greenwich, I can't think of anything that is still around.
Observatory. But there's a whole world before all this about shipping, which I know you mentioned, but all sorts of devices which were developed. And also, I mean, what went on in the arsenal? The article I did last week, where I know the British government headhunted this chap from Germany and France, but it's about to develop technologies and how to do things. In, this is the mid 18th century. It's about ammunition. It's about fortifications, but it's still working, buying technology in and building.
Yeah, it was a huge. Yeah, I mean, not just testing armaments, but actually developing a lot of real basic research. And of course, you remember as well as I do that Mr. Shrapnel was the director of the Woolwich Arsenal.
Military officer.
He was, yes. But,
somebody else very interesting is what's his name? The chap who's the explosives expert. Yeah. But there's a whole lot of stuff there.
Yeah.
You know what went on a lot of the time.
And of course, it was definitely secret, and that's why Elliot did a lot of work for the military and for the aircraft industry, and so that's why it's really hard. I had a conversation with Dan Hayton about it, and we're both sort of vaguely interested in. I wonder if there's anything we could find out about Elliot. There's just very little about it. I don't think where the records are. I mean, there's so much material here. If somebody who was, 10 years younger than me and had time on their hands wanted to do a PhD, it'd be a wonderful scope for PhD of London's role in technological research and of course why it lost it. And is it a coincidence that it disappeared at the same time as Britain's manufacturing industry and mining industry and steel industry and all the other things, that we became a deindustrialized nation in the 1980s? And I could make that obvious political point, but I'll assume you're all bright enough to know where I'm going with that. It was a sort of lack of appreciation of the importance of manufacturing and technology, which we still see today. The government makes an announcement about how much it's going to put into artificial intelligence. And you say, well, this is a tiny fraction of what Google, one company, is putting in the States. You think this is pathetic. They do not understand, these people in Westminster. There's so much they don't understand, and technology is just one of them.
Yeah, absolutely. Anybody else out there? Bill, you still there? No.
I think we should close. It's 9 o'clock.
Okay.
I need to make my supper.
I put the chat, I put on chat the program, which I've done so far for the rest of this year. If we get an edit calls out, do a talk on William Joyce.
Yeah, great.
Which I've just written.
You're better informed now, Elizabeth, about the format. Yeah.
Thank you very much, Alan.
We're not expecting a full hour. I mean, that's
no.
Ever, sorry. Okay.
Yeah, it's been very interesting. Links with a lot of other things.
Good. Okay, I will. If this is this, I will download the recording of this, and at some point I will edit it and put it onto the YouTube channel. And I've got about 6 others to put up there. But as I'm now on a sabbatical, I've probably got time to do that. Now I'm not going into work every day, so I will do that as soon as possible during the summer or early autumn. So and post it on the Facebook site. And we have some other projects that we're talking about at our next committee meeting, aren't we, Mary?
Yes, which is on Thursday.
Okay, right.
Right.
Okay,
Thank
then.
you.
Bye-bye, everybody. Bye-bye.
Thank you.
Bye.
Bye.